So now let's look at interpreting an ANOVA table in SPSS by looking at the data for paper 2. So hopefully by now you know that for paper 2 we are using a 2 by 2 factorial design. So the first independent variable is the race of the participant. There are white participants, there are Hispanic participants. The second independent variable is the level of threat. So either there is an economic threat or there's no economic threat. So this is based upon the whole 2013 paper that we have been talking about since the beginning of the semester. The dependent variable is the degree to which participants categorize Hispanic white biracials as in-group members, with higher scores meaning that they view them as being more a part of their racial in-group. So to give you a sense of what the threat condition looked like, participants read that a 2011 survey of 25 Fortune 500 companies revealed that the number of Hispanic individuals in managerial positions at these companies had increased dramatically since 2000. In 2000, workers identified as Hispanic represented 5% of all employees with managerial responsibilities in the surveyed companies. Today, they represent 18% of all managers. During the same period, the percentage of whites in managerial positions had decreased from 75% to 63%. So Hispanic managers are increasing, white managers are decreasing. In the no threat condition, or what you consider the control condition, they read about the same survey. They were told that in 2000, workers identifying as Hispanic represented 5%. Today, they represent 6%. And during the same period of time, whites in managerial positions had remained the same, right? So there's no threat here because nothing is really changing. Now, that's our manipulation of the independent variable of threat. Our hypotheses are that there will be a main effect of participant race. Specifically, participants who are Hispanic will view Hispanic white biracials as more a part of their racial in-group than participants who were white. There'll be no main effect of threat, but we are hypothesizing an interaction between race and threat. There'll be an interaction between participant race and threat on the in-group categorization of biracials. White participants in the threat condition will view biracials as less in-group than white participants in the no-threat condition. Conversely, threat will have no effect on Hispanic participants' ratings of biracials. So in other words, when whites are threatened, they'll view Hispanic white biracials as less a part of their in-group than when they're not threatened, and Hispanics will be unaffected by that threat manipulation. So when you run an ANOVA in SPSS, it gives you two tables, a descriptive statistics table and an ANOVA table. For now, we're just going to focus on the ANOVA table. In the next lecture, we'll incorporate the descriptive statistics table and the ANOVA table. Ultimately, you need to understand both to be able to understand the output. But let's start out with just the ANOVA table for now. So, my advice is draw a line through the first two rows, the corrected model and the intercept rows. Those don't give you any useful information. It's the next row going forward that matters. So, race of the participant, that's what we're going to look at to determine whether or not we have a significant difference between white participants and Hispanic participants, right? So we're looking to see if there's a main effect on that particular variable. And for that main effect, we don't care about whether the participants read the threat survey or the control survey, just that they were either white participants or Hispanic participants. So the first thing you want to do is understand the variability for those who were white versus Hispanic, and comparing it to the variability from our error term. So to understand our between groups, we take our sum of squares. Again, I don't need you to understand much about sum of squares for now, but you take your sum of squares, you divide it by your degrees of freedom. The degrees of freedom for an independent variable with two levels is always going to be the number of levels minus 1. So there's 2 levels, so the degrees of freedom is going to be 1 here. So we're taking the sum of squares, so dividing it by its degrees of freedom, and that gives us our mean squared. Same thing for our error term. This is where we're going to get our within group variability. We're taking the sum of squares for that, dividing it by its degrees of freedom. The degrees of freedom for the error term for 2 by 2 is number of participants, which is 166, minus the number of conditions. And a 2 by 2 has 4 conditions. So now that means we have 162 degrees of freedom. So if we divide 344 divided by 162, we get 2.127. All right, so this is our between group variance and our within group variance. All right, so our between is a 70, our within is 2.127. That is what we use to determine our F ratio. We take that 70.105, that's our between group variance, we divide it by the 2.127, which is our within group variance. So if I were to ask you to tell me what the F ratio is, you would say 70.11, if we're going to round, divided by 2.13, again if we're rounding. That is the ratio. If we divide those numbers, we get an F value. This F value of 32.958 is simply that 70.105 divided by 2.127. If we divide those numbers, that ratio, this is our F value. Okay? Remember I said if you have a sample size of 60 or more, and you have an F that's greater than 3, you're likely to have a statistically significant result. This sig column here, this is our p-value. So the probability of getting a F value of 32.958, if the null is true, is 0.0001%. So it's extremely small. It's less than alpha, so it's very unlikely to get that particular F value if the null is true. So as a result, when we compare this p-value to our alpha level, we're going to end up rejecting the null hypothesis because our p-value is less than alpha of 0.05. So if we're going to write this out in correct APA format, the first thing we want to do is tell the reader what statistic we used. Then we tell them our between degrees of freedom, then our within degrees of freedom, the actual F value, and then the P value. So if we write it out, we have an F here, 1 for our between groups degrees of freedom, 162 for our within groups degrees of freedom, and then an F value of 32.96. And we say our P is less than 0.01. So if we're setting our alphas to be the most stringent at 0.01, we're saying that our P value is less than that. So this would tell the reader that we have a significant main effect of participant race. Now, remember, an ANOVA is an omnibus test, so it doesn't tell us which one is higher than the other. It says that they're different. When we introduce the descriptive statistics table, we'll be able to see which condition or which race is different than the other, which one's higher than the other. All right, so now if we want to understand if we have a main effective threat, we're going to now go to our threat condition row here, right? So again, we have our sum of squares, we divide it by its degrees of freedom. Again, since there's 2 levels of the threat condition, it's 2 minus 1, so our degrees of freedom for the threat condition is 1. So we're going to divide now that 0.04 divided by 1, which obviously is 0.04. So our between group variability is 6.04. For our error term, it's the exact same numbers, right? We're taking that 344.592, dividing it by its degrees of freedom. We still have that same 2.127. Right? So now we have our between group variance and our within group variance. So our F ratio is 0.604 divided by 2.127. If we do the math, that gives an F value of 0.284. The probability of getting an F value of 0.284, if the null is true, is essentially 59.5%. That's way higher than our 0.05, which is our alpha level. So that means we do not have a main effect of threat condition. So in other words, those who were in the threat condition did not differ from those who were in the control condition. And down here, we just give you the ratios and the F value again. All right, so again, if we were to write this out, we would report that we have an F, and this F should be italicized. Our degrees of freedom for between is 1. Our degrees of freedom for within is again 162. Our actual F value now is 0.28. Our P value for rounding here is 0.60. So in other words, we do not have a main effect of condition, of threat condition. If we want to know if we have an interaction, then we're going to look at this race of participants by threat row here. Then we're going to take its sum of squares divided by its degrees of freedom. It's always going to be -1. So our mean squared, or our between group variance, is going to be 8.697. We're dividing it by the same within group variance of 2.127. So our F ratio is 8.697 divided by 2.127. That gives us an F value of 4.089. The probability of getting an F value of 4.089, if the null is true, is 0.045. That is, or essentially 4.5%. That is less than alpha 0.05, which is 5%. So as a result, we should say that we have a significant interaction between race of the participant and threat condition. And again, this particular table does not tell us the nature of that interaction. It just tells us that we have an interaction. When we get to understanding the descriptive statistics table in our next lecture, we'll be able to then understand the nature of this interaction. But for now, we know that we have a main effect of of race, and we have an interaction between race and threat condition. So if we were to write out these results, again, we would report our F in italics, our between groups degrees of freedom of 1, our within groups degrees of freedom of 1.62, our F value of 4.09, our P value is equal to 0.05 if we're going to round. So that's basically the cutoff. So here's one way that you can write up the results of that previous analysis. So just like in paper 1, you can use this write-up as a template for how you write up your results for paper 2. But this is essentially the information that you need to report. Consistent with our first hypothesis, the results of ANOVA indicated a significant main effect of race on group membership. And you report the statistics for that main effect. Now you got to explain the nature of the main effect. Hispanic participants were more likely to categorize Hispanic white biracials as part of their racial in-group than white participants. Then you got to explain the other possible main effect. There was no main effect of threat on participants' categorization of Hispanic white biracials. And then you report the statistics for the threat condition manipulation. Then you have to now explain the interaction. There was a significant interaction between the race of the participant and threat condition. Then you report the statistics for that interaction. Now you got to explain the nature of the interaction. In support of our hypothesis, white participants in the threat condition categorized Hispanic white biracials as less a part of the racial in-group than white participants in the no threat condition. Contrary to our hypothesis, Hispanic participants in the threat condition categorized the biracial targets as more a part of their racial in-group than Hispanic participants in the no threat condition. I know that's a lot. We'll spend some more time talking about it in the next lecture, but I just wanted to give it to you now so you can start thinking about how you're going to incorporate it into your paper.